All right, good afternoon, everybody. Welcome to the AI session. Hope you're doing well. Good morning. Yes, let's go. Yeah. They were too quiet for me in the main room, so we're gonna have some fun here. Good afternoon. My name is Sudhir Mata. I run products here at HPE Networking. It's Aruba Networking and Juniper Networking. It is a mouthful to say all of those words. We are one company now, but thank you for joining. Thank you for taking the long trek from there. I only have one question before I introduce the rest of the team and we start off. How many of you run today a Aruba wireless network? Show of hands. Say 60, 70%. How many Juniper Mist wireless networks? More than I thought, maybe. Yeah, so about 10, 20%. So this will be good. This will be our AI journey. So this is AI for networks, the journey for self-driving. As I said, Sudhir Mata, I am product management for Aruba Wireless, Aruba Central, obviously Juniper Mist, wired and wireless, and NAC as well. So we have a very awesome panel today. First is Bob Friday, the original founder of Mist, the CTO of Juniper Mist, and now the Chief AI Officer for HPE Networking. Then we have Jose Toledo. Jose is the AI lead for networking from an engineering perspective. And then, of course, the best part of the show is Kevin Brew, our customer from Royal College of Surgeons in Ireland. So we will have a fast-paced show. We may have some time at the end for questions. We will see. But if not, if we run out at 45 minutes, if we have questions, all of us will be outside the room. They told us a million times, do not ask questions in the room. We got to do that outside. So without further ado, the one, the only, Bob Friday. Thank you, Bob.
Thank you, Sudhir. Yep. Good afternoon. It is great to be here with you in Barcelona today. In this session, we're going to be taking a look at where HPE is on the journey to self-driving network and where some of our enterprise customers are. Now, I can tell you, when I started Mist in 2014, investors, customers, they were all skeptics that AI networking was going to be relevant to their networking problems. Now, we met with about 50 or 60 customers back in September, and every year I'd ask them, where are you on the journey? I would say this is the first year there were no skeptics in the room. I had no AI skeptics in September. Any AI skeptics? Do I have any AI skeptics left in the room? I would say most of them were in the category of they knew AI was going to be relevant to their business, but they weren't quite sure how to separate out the gap between AI marketing and AI reality. How many people were in the, hey, you know AI is relevant, but you're still trying to sort out the gap? Do I have anybody in that category? And there were still a few that were in the, hey, AI, they knew they were embracing AI, they were actually using it. Quick forward-looking thing, even while we're still the AI native market leader, the AI crystal ball is not perfect yet, so take it with a grain of salt. Now, for me personally, the AI journey started when I was at Cisco, and I was trying to sell some large retailers a customer mobile experience to put on their wireless network. And the CIO there told me, Bob, I'm not putting any customer-facing app on this network until you could promise me your controllers will stop crashing. She wanted to make sure that I could deliver innovation faster than twice a year. But more importantly, what she said is I had to guarantee that her users were going to have a great wireless internet experience. And that's when we kind of realized, Suji and I realized that, hey, there was a fundamental paradigm shift happening from just managing network elements to actually managing the client-to-cloud user experience. So that's when the journey started for me at Cisco, when we founded Mist. Now, I would say the other critical thing, the reason I am still here pushing the self-driving rock up the hill is because Agentic AI is now part of our toolbox. The second reason I'm still here is because we have two world-class data science teams that have joined forces and are unifying to get their shoulders behind one cloud AIOps effort and one vision to get to self-driving network. And that's Jose over there. I don't know if you guys meet Jose. He leads the data science team at Aruba. Now, for those of you who know me, I make 1 barrel of wine a year. I always say, great wine starts with great grapes. Great AI starts with great data, right? And the reason that Sujan and I built an access point at Mist wasn't because we thought the industry needed another access point. It was because we wanted to make sure that we would get the right data, the data we needed to actually predict and optimize the wireless user experience. And last year, or this year in May at Mobility Field Day, what we announced was Marvis Minis, right? And Marvis Minis is a synthetic digital user that we've integrated into every access point, router, and switch. And what we've now extended that to with joint forces with HPE Aruba is we're now starting to integrate the UXI, the user Cape Networks, user experience insight thing. We're starting to integrate that into Minis. And that's going to allow us to basically bring the ultimate observability, visibility from client to cloud application. Now, once you have the right data in the cloud, you need to put it into some form that you can apply math, simple math or fancy math to it. And with the paradigm shift to cloud, what we have done, we keep track of every user on the network. And we keep track of every user minute on that network. And that's what we call SLEs, service level experience metrics, right? That's what allows us to now take data science and basically figure out and predict and remediate every bad user minute on our networks. And what we announced this year at Mobility Field Day was the generalized large experience model for Zoom and Teams. Ultimately, your Zoom and Team users are the canaries in your networking coal mine. If anything goes wrong on your network, packet loss, jitter, latency, it is going to be those video collaboration users that feel the pain worst. So this is like a large language model where we can now predict the user experience, the video user experience on your network. This is the second generation in service level experience metrics. Now, when it comes to data science, we all have access to the same data science models. We all have access to the same PyTorch, TensorFlow libraries. What makes HPE different is HPE is the only vendor that uses its own cloud AIOps solution in customer support. You know, and my claim is if a networking vendor is not using their own cloud AIOps solution yet, they have not started the journey to self-driving. Now, since starting Mist, I have always been a big believer that natural language is the next user interface in networking and other verticals and industries also. You know, the Marvis has had a natural language interface since 2018. It did a very good job of understanding questions you were asking, but it wasn't until we got ChatGPT and Agentic AI that really gives Marvis a voice in the reasoning now. We are at the point now where I think you will see the Marvis CI, Agentic AI, this will become the preferred interface versus navigating dashboards. We went from CLI, dashboards, Agentic AI, conversational interface is the next user interface that you will be using to understand what's going on, troubleshooting your network going forward. And finally, we get to Marvis Actions. This is the self-driving promise and vision that we have been working on. And this year at Mobility Field Day, you'll see Marvis Actions 2.0. And what is that bringing to the party? Is that is making sure that anything that we recommend, we are going to be automating. If you look at Agentic AI, it is basically a new nonlinear, non-deterministic software programming language. It is going to let us automate things that we have not been able to automate before. For all of you, how many of you guys are playing with MCP servers and NAT or LangGraph, right? Yeah, this is it, right? We're going from Python scripts to now we're going to be MCP servers, learning how to basically program agents, graphs of agents going forward. Now, as I said, since starting Mist in 2014, since 2018, every day, the customer support team at HPE, Aruba, Mist now, uses its own Marvis Cloud AIOps solution to basically resolve support tickets. Resolve, reduce support tickets. Customer support is the ultimate customer for HPE, Aruba, Mist. It is a proxy for you. The fewer tickets my customer support team sees translates into better user experience for our customers. The fewer tickets they see, or the fewer tickets you are sending in. And this is why this is probably the other critical part. When Suji and I left Cisco, we knew that we're going to have to build a whole new cloud architecture. We knew a blank sheet of paper was going to be easier. What we quickly discovered is organizationally, you need to tie your support team, which are the experts in networking, to your data science team. And that was probably the other secret to actually getting all this stuff to work, is making sure those domain experts and those data science are working side by side on a daily basis. Now, when we talked about Marvis Minis, this is something Sudhir is excited about since we started it. For those who know Sudhir, there's only two problems with Wi-Fi networking. The first thing is you can't connect. The second thing is Wi-Fi sucks, right? You only have two problems that we have to deal with. And when we have users on the network, we have plenty of data to figure out those two problems, why you can't connect and why you are having a slow, bad experience. Now, what happens when all those users are not on the network? That is where full stack Marvis Minis comes into play. We have integrated Minis into the AP, the access point, and the router now to basically ensure that all your critical network services, DHCP, DNS, are up and running and ready when the people walk into the door. And to make sure any business critical apps are up and running before you start your business. So that is a big thing that Minis is going to bring observability, client to cloud application observability that you have not had before. But taking that a step farther, when you start putting Marvis Minis into the campus branch, and then you stick it into the POPs, internet POPs, stick it into the service provider network and stick it into the cloud application. This is what brings complete client to cloud application visibility into your teams. And more importantly, what we announced this year at Mobility Field Day is basically Marvis Mini SLEs. Beyond just giving you observability, this is bringing root cause analysis to party to help you start to understand why is your pre-connect services having a problem or why your application is having a problem. With that, we're going to bring it down to more reality. I'm going to invite Kevin up here. We're going to get down to the nitty-gritties of Kevin. Come on up.
Thank you, Bob. So, firstly, apologies for my voice. I woke up with no voice this morning. We're doing okay. Okay. My name is Kevin. I'm the network architect in RCSI in Ireland. So, what Bob is just presenting is complex and very high level, or low level if you want to go that way. But for me, this is reality. Okay, so every morning when I arrive to work, I have a narrative, and the narrative is everything is green. From a user's perspective, excuse me, everything is green. So you can see here, all my buildings are listed, and Marvis Minis has been testing DHCP, ARP, DNS, and application all night, 24/7. Everything's going fine. Okay. sometimes it detects problems. So this is failed DHCP infrastructure. Everything is exploded, but it's contextualizing this that I can give it to another team who can then resolve the issue. The issue can be resolved and we can move on. The big thing with this is that the narrative is now there and I can say everything is okay. I can guarantee everything is okay. We can move on. We can go about our day. It's not the network, it's a systems problem, or it is a network problem. Minis will diagnose this for us. So Bob mentioned SLE, sorry, I can't see letters. You mentioned the Minis SLE, which is the user perception of how the network is performing. So you can see here, my network is performing at 99%. This is a real metric, a metric of actual performance. And you can see lower that when I do have an issue, of the 1% of problems, what's my number here? I can't read that far away. 83% of that 1% was DNS. And 79% of that 83% was captive.apple.com. The network is still okay. We can move on. Everything is fine. And with that, I'll hand over to Jose. Sorry about my voice again.
Thank you, Kevin. So my name is Jose Tellado, and I lead the AI for HPE Networking. So I'm first going to introduce you to a model that Mist customers have been benefiting for at least a year, the generalized large experience model. As Bob said, there's actually two main issues. Getting on the network, and once you're on the network, are your applications healthy? So this model predicts for every user, every client minute, if you're going to have a good experience on a real-time application. This model has been trained on both wired and wireless features, so you can know if the issue's on your LAN, or it's in the radio, or it's in the roaming, where it is. And once you predict, and you have a model that predicts, you could use this model also as a feature importance model, so you can know when it fails, what are the features that explain the failures, so you could root cause and remediate the problem. So this model has been available on the Mist platform for a while, trained on billions of client minutes. But as many as you know, those of the 10% and the 60%, the Mist and Aruba platforms are very similar architecture-wise. They share a lot of the same telemetry, and it turns out that all the features that are being used for the generalized large experience model on the Mist side are actually available on the Aruba side. So the obvious question is, why don't we deploy this model on both? So that's exactly what we did. As the two teams came together over the summer, within 1 month, we were able to get the large experience model that was trained on Mist data, and we deployed it on Aruba Central. And Sudhir will actually show you a demo shortly. But before he shows you the demo, this is not where we're stopping. Given that we have two teams, we have bigger data sets, we have new features like the UXI sensors and the Marvis Minis, and more new inline telemetry coming from AP switches and gateways. So going forward, actually in the next few months, you're going to see how the large experience model is going to get even better with more fine-grained root causes and more accurate recommendations. Sudhir, please show them the model on Aruba.
thank you. 60% of you, or more than that, are Aruba customers. So far you're thinking, what's in this for me? And so here's what it is for you. So this large experience model is going to translate into a application experience predictor on Aruba's AI Insights. And so what that means is, if you go to these AI Insights on Aruba Central, essentially, without even connecting to Teams and Zoom, right? We've been able to actually learn the Teams and Zoom data on the Mist cloud. And so without even connecting now to Teams and Zoom on the Aruba side, this application experience predictor, I can go into the Bangalore campus and say, what percentage of my user minutes for Teams and Zoom are good and bad, right? And then, if, let's say I pick that site, now I want to understand all right, I have 3,000 user minutes happened on the 14th of November. Looks like about 1,000 of them are bad. And so you can actually see every user, every minute, every Teams call, a prediction on if the Teams call are going bad, and if they're going bad, why are they going bad? And that's what the bottom half of this is talking about, is the client experience contributor. And so what is contributing to the likely failure? So what we're doing is, we've done all the training on the Mist side, and we've moved the model over to the Aruba side, and now Aruba customers are able to get value from the Mist innovation, right? This is the power of these two companies coming together and immediately collaborating and not fighting, and really Mist engineers writing code on the Aruba cloud and Aruba engineers writing code on the Mist cloud. This is happening right now. We are less than 6 months into this acquisition. This is my 4th time getting acquired. I've not had such kind of collaboration. And as you can imagine, Mist and Aruba were heavily competitive companies until July 1st. We were at each other's throats. On July 2nd, we're suddenly brothers and sisters. That marriage happened very fast. And so this is proof that these teams are coming together, are going to bring value to where you are versus asking you to choose between platforms and stuff. Yeah. So next up is, all of the rage is agentic AI. Jose has actually been leading this agentic AI initiative on the Aruba side. Aruba has launched Agentic Mesh at Discover Las Vegas. Lots of exciting announcements. And so Jose's team has been heads down. They've actually now started to leverage this onto the Mist side. So Jose, what does this mean to you, and what are we doing?
Okay. So as you all know, people cannot stop talking about agentic AI. But today, you're going to see it in action on both the Mist platform and the Aruba platform. And please go to the innovation zone. You could ask your own questions there. But as Sudhir said, this is one where Aruba was ahead of Mist. But the two teams came together over the summer. And right now, whether you are on the Mist side or the Aruba side, they have the same architecture that's shown in this diagram, which basically means we layered a reasoning model on top of classic AI system that has data, knowledge bases, and classic AI systems going into a reasoning model to serve two main use cases. One is the network admin wants to ask questions about the network. Why is DNS slow? Why can users not get on the network? Or the alternative is that the system automatically detects that the network is not meeting KPIs. DNS is slow, people get out on the network, and automatically triggering the reasoning model. The benefit this reasoning model has over the classic AI is that the classic AI system, the AI designers have to go pick the features, train a model to solve a finite number of problems with a finite number of inputs. But as you can imagine, in a full stack network between a client and the cloud, there's thousands of things that could go wrong, and the AI engineers cannot think of every possible thing could go wrong. So the architecture you see here, basically the reasoning model behaves like a network admin, and it has access to all the data, whether it's your customer-specific telemetry, knowledge bases that are learned for like 10 years of history of support, and all the classically trained models that optimize things like predict or optimize things like the recommenders in Aruba or the predictors for LEM. But basically what happens in that middle box, the reasoning model, is either human or a self-driving agent will trigger it. It will reason through the problem context. They'll decide what are the steps to solve the problem. The steps usually require accessing the data system on the bottom, which is the classic AI system that both the Aruba and Mist have been building for the last 10 years. When it retrieves the output, it has to figure out, do I have the solution to a problem or not? So in that reflection stage, if you don't have the solution to a problem, you go back to the beginning, retrieve more data, get more context, and iteratively get to the bottom of it. If you can imagine with this system, you actually have exponential number of problems you could solve, because every single time you get more data, you could ask a follow-up question and keep behaving as humans that troubleshoot the network, which is much more broad, thinking outside the box, than what classic AI could do until the date. So just going ahead, Sudhir, why don't you show them the demo on both the Mist and Aruba platforms?
Yeah, no, this is really powerful. I hope all of you, by the way, let's do I know it's still, we've not fed you lunch, but I want an actual show of hands. How many of you are working on MCP servers and actually doing something with Agentic AI in your enterprise? Show of hands. Wow, okay, you were actually raising hands and still the 5 people. Okay, the rest of you really should get on with it. It is fundamental as to how enterprise will engage with data, so leverage that. So what are we doing? What we are doing is, on the Juniper Mist side, I'm going to start on the Juniper Mist side. You'll see the Aruba side as well. Basically, we have historically, we've had a Marvis conversational assistant. And so the Marvis conversational assistant, I didn't click the button. That's why it's not going. There you go. The Marvis conversational assistant is you ask a question, right? And so, are there any network issues at our Sunnyvale headquarters? The fundamental difference between an AI assistant and an AI agent is the agent is able to actually ask a question, get an answer, and then ask a follow-on iterative question based on the answer that has come about. That's the fundamental difference. This is not a one-and-done concept. And so consequently, here, that reasoning that was built into this step-by-step is game-changing. That is the key difference here. And so here you're saying, hey, we know now who's impacted, what evidence we've collected, and what root causes it likely is, and by the way, what recommendations are we recommending, right? So we are super excited. If you're an Aruba customer, how many of you are on Aruba, the new Central, the Central CNX? A few of you. The rest of you are getting there. If you're on New Central and you have the advanced subscription, this is available now. Jose is actually looking for customers to ask questions and give us feedback. If you don't like an answer, let us know, because it only makes us better. For the first time, we can legitimately take an answer, and when you give a thumbs up and thumbs down, super important, that immediately goes into the reasoning model to be able to give a better answer the next time, right? So very, very important. Top of mind innovation for us. As Jose said, this is not, we answered these 5 questions in Q1 and these 5 questions in Q2. No, this is broad. Challenge the system with whatever the problem you have. And Bob always, as Bob said, every single support ticket at Juniper Mist, 100%, every single customer support ticket that any one of you open on the Juniper Mist side, we already are passing through multiple AI models. The very first one, of course, is Marvis. And so we document the answer. Every single time, we document the answer Marvis gives. And if Marvis doesn't have the right answer, that's what you saw in Bob's thing at the very top. We go and make it better. So it's really important you continually provide feedback to us. We're super excited about it. The last thing on this AI journey, very good. Similarly on the Aruba side, again, this is what you will see on the Aruba Agentic dashboard demo. This is the Copilot button. You click on it. Again, same thing. What I really like about this, at the end of the day, if you think of what we're trying to do here, we're emulating the human behavior. For the first time, the problems don't have to be very structured. In this case, it's a random question. Obviously, it's a recorded video, but literally, you should ask random questions because the system is capable finally to say, okay, I'm having roaming issues over the last day, focusing on client impact. I want a chart indicating how it's impacting my clients and give me those specific clients, right? Somebody came and said, hey, we were walking from building to building or venue to venue, floor to floor. The thinking part of this is the reasoning part of it. That's the iterative, okay, give me this answer. Okay, if the answer said something about DNS, something about DHCP, that's where I start digging down that rabbit hole, right? Very, very fundamental. And so this is why you actually do, by the way, how many of you use ChatGPT's deep research? A few of you, highly recommend it. Notebook LM, if you're using it, highly recommend it. Game changing in terms of the impact. This is very similar to that, right? And so, again, as you go through, it'll come back and tell you, and get you to all of the exact sites, the summary, and what remediative actions, all this kind of stuff. This is available for Aruba customers today, right? So please try it. And if you don't have the subscription, please buy it, and then you will immediately have this feature. There is no magic to that. With that, let's go to the next one. Self-driving. I want to define this for a moment because it's an easy term everybody's throwing out. But for us, for Bob, he's made it his absolute life mission, and that means it's our life mission. So let me define what we mean as self-driving, when do we do it, and what do we do? So how many of you have taken a ride in an actual driverless car, a self-driving car? A few of you. Please, the rest of you, come to San Francisco at your own risk, drive the Waymos, ride the Waymos. They are amazing, right? Because here's my experience. Bob has driven one in Phoenix, and he asked me to ride one. I got in one in the airport. My wife drives a Tesla. We have other cars that have some kind of self-driving capabilities. But when I got into this driverless Waymo, that thing drove like a New York cabbie driver. It was weaving through traffic cones and people and avoiding. It was zooming fast. That was the light bulb moment for us. If it in real time, a system is able to actually navigate like that, why couldn't we do this in the network? That's why we are on this mission. We genuinely believe we will get you to a self-driving place. And what does that mean? What that means is there are two types of actions. The first action is, Marvis or Aruba Central will tell you there may be a bad cable. I can't self-drive a bad cable. Somebody has to go fix a bad cable. However, if there are problems intrinsic to our system, right? Problems where, hey, I should have turned on dual 5 gigahertz. I should have turned on 6 gigahertz. I should have, I saw a loop in the network. I should block the loop in the network, detect the loop in the network. There are so many examples. So Bob's mission is, if there is anything that's intrinsic to our system that we have configuration control on, with high efficacy, with permission, we will not self-drive anything that you don't allow us to self-drive, and we have a notion of a trust. But if you trust and you give us permission, we will remediate problems for you. So I'm going to show that to you in a demo. Kevin, you have enough voice to do one more slide for me?
I think so.
Please, I brought you all the way from Ireland. These people are expecting you to say something.
Oh, thanks.
So, here we go.
Okay. Hello again. So this is the octopus, is what it's called. This is just basically highlighting that I have access points offline. So you can see I have 3 offline here. The reality of this is they just need to be rebooted, but this is how it's presenting the problem to me. It also presents things on large scale when things explode. So here's the earlier DHCP problem, 105 actions, all DHCP related. And I just want to highlight that this was the beginning of a serious DHCP problem that we had. And all of these problems were highlighted by Marvis actions. We ended up replacing our entire DHCP infrastructure based on these alerts. And not just the big explosions, but the minor ones. They were all building up into something far more major. So to take something like this is very simplistic. And to make a decision like that has large financial consequences, was a big deal for us. And it was correct. We've upgraded to efficient IP and everything works now, so a great success. So the self-driving element, this is my dashboard, so it can fix non-compliant wireless access points, like wrong version. It'll upgrade them automatically. You'll get everything aligned in a single site. A stuck port, so port is up, no traffic. it will bounce the port repeatedly to try and get traffic to flow. If it doesn't flow, I have to action this and I have to fix the problem. And the WAN connectivity speed, intermittency is based on SSR or WAN edge, basically. Oops. So my point with this is it's very simple. You know, we're coming from a very complex place. Monitoring is one thing, but this is experience. How is it actually performing? And it's really changed things in our university. So
I feel like I'm putting you through human cruelty, so I'll put you out of your misery. Thank you so much, Kevin. Well done.
Right.
Super well done. Thank you. So this is, for those of you who are Mist customers, you know this is the Marvis dashboard. As you saw in Rami's keynote, this Marvis dashboard is actually going to make its way onto the Aruba side. Again, as we said, we are genuinely trying to, this combined forces be of value to both customers, right? So, think of it as, your mobile apps, such as, say, United Airlines or British Airways or whatever airlines you fly, that app is built once, but is deployed on an Android or an iPhone. We want to think of Aruba Central and Mist Cloud as Android and iPhone, but the value we deliver to you with AI is the app that we are writing. And that's the common code that we're writing. And that's how we feel conviction that we could deliver value to you on as a joint team. Now, here's an example of a self-driving action that the system on the Mist side is going to take very shortly. This is essentially to say, if a self-driving action has already happened, let me see. Yeah, there you go. Essentially, this is showing you the homework of what happened, right? So essentially, there was a network loop caused by a broadcast storm, right? And so now that already happened. We shut down the port that caused the loop, okay? Now we're showing you the homework of how we actually went through this process. The first step was, and by the way, this is all LLM generated, loop detection, the topology identified that there is a loop happening. Then the port connectivity analysis says, okay, did any ports flap during that exact time? Right? And then ultimately it comes to, okay, on that switch, we are seeing a broadcast spike, and that is, 1900 times abnormal. And so quite a few SDP loop detection events happen. And so ultimately, the system will tell you exactly which port that it saw as the root cause as to right before the storm happened, what port had the spike. And by the way, completely generated by agents. This is if you remember Jose's picture, there is human-generated questions that we are asking, and then there is agent-generated activity. This is an agent waking up and saying, aha, there's a loop in the network, I got to detect which port, I got to shut down the port, and I got to bring the network back. I was on a 4-hour, hospital network outage escalation 2-3 years ago. This would have saved 4 hours of hospital network issue with probably sub-second recovery, right? This is the power of self-driving networks. So with that, I want to bring up the rest of my panel. Please come on up, Bob. We have exactly 6 minutes. Maybe we'll take 2-3 questions. Any questions at all? Anything top of mind for you? Are you calling bullshit on this? Do you feel like this is the right direction? Does this make sense to you? The hardest questions are the best ones. So, yes, sir. Great question. So let me repeat the question. So love the idea of self-driving, but we are a structured enterprise that have a very rigid change management strategy, and I do not want somebody randomly self-driving my network without change management, right? And so Our answer is actually quite simple. Again, initially, we're going to just alert you, hey, there's a loop, here's the port, here's the spike, here's everything we found out about it. You could go take the action, right? And after a few times, you will realize, and this is our hope and this is our experience, is that we have high efficacy. We will only self-drive when we have near 99-100% efficacy, that we know exactly this port is the one that caused it, and shutting this down will actually bring your network back. You will find that people will be okay that, you know what, if the network broadcast storm is going to take my network down for 3 hours, I'd rather actually it self-drive and alert. But it is a trust. Every enterprise will have a different barrier of trust. That's why you have the finger on the pulse.
And are you a ServiceNow or your change management ServiceNow? So we're tightly integrated with ServiceNow. So for some people, self-driving means please send the request up the food chain.
Yeah.
And so I think we're going to get a game of agents talking to agents going forward.
There's one more hand I saw here. Yes, sir. Yeah, so good question. So the question is, how does this comply with, from a data security perspective, how do we make sure we're not contaminating your organization's data with anyone else's data as we go through this process? Jose, you want to take that?
Yes. So for training these models, we only keep the metadata. There's no personal information in the data. It's just the metadata. It's like a client iPhone failed with this much time, and that's what we keep. We don't keep the user identity or anything like that. So when we train these models, there's sanitized. On the knowledge basis, it's sanitized support data that's been used. I didn't mention it, but the knowledge base includes the 10 years worth of support cases. So to help each customer, we use all the bad experiences over the last few years that every other customer had, but it's all sanitized. It's just the subject, the remediation, no customer name, no PII data in there.
That's why at a certain stage we need to deal with this to fit our models
Of course, yes. 100%, yes. Okay, thank you. Last question, I think over here, please, yes.
How was the start? What kind of efficacy you achieved when you started, and how it improved over the period of time that you have enough conviction to come and stand in front of us and asking us to try it?
Yes,
Yeah.
Bob?
So this is my favorite topic. So I make sure customer support uses Marvis for every support ticket. I would tell you, if you went there, look at that chart, we're up by probably 70% of the time, 70 to 80% of the time Marvis is helping solve a support ticket. Now I suspect with Agentic AI, we have not moved that needle for a year or two. We got up to there and we got kind of stuck. Agentic AI is going to let us start moving that needle up to 80, 90%. Because Agentic AI is going to let us start to get to the next level of problems that are hard to solve. So I think that's my answer is customer support. I make sure my customer support uses, why would I ask you to use it if I don't have my own support team using it?
Yeah, so it's a great question. Efficacy is everything. That's why we've publicly presented the chart for the last 7 years that we've maintained the data. For this agentic efforts, I would say we started with the 10, 20%. When you put an MCP server on any API, the initial answers look very interesting. And after that, it's a much harder hog to actually, go down that path. We've gone, 10, 20, 30, 40. It is very intentional work. It's not an accident. We didn't start at 80% efficacy, far from that.
By the way, what Sudhir said earlier, please give feedback.
Yeah.
Please, the Aruba system is live for advanced licenses. There's about 500,000 devices that have licenses. Please give feedback. It's sitting around 70% effectiveness. We want to get up.
And I think she's throwing the hook out.
Yes.
Big hook coming out.
We have to be out of here. 1 minute.
Very good. Okay, thank you everybody. We are here. Join us at the expo. Thank you very much for joining.